My name is Caio. I'm from Brazil. I have a bachelor and master degrees in computer science, and I've been working with Ruby and Rails since 2008. I work for a company called Midan in San Francisco, where I'm an engineer since 2011 there, and have been working with Rails there since 2014. So it took me 3 years to convince them to migrate. So we have this tool for fact-checking fake news since 2012. So it's a pretty old software. So it used to be a Drupal monolithic web application in PHP. So you can imagine how hard it is. So after a few years, we were able to migrate from a monolithic Drupal app to a microservices architecture with a Rails backend and front end in JavaScript using React. So what I'm going to talk today is about the technologies involved in this architecture that we have, and the role that each of those technologies play in this environment, and how it works for us, and how on the front end we are able to have the same code base that we can work in different environments, for example, on the web, on the mobile, as a native app, not as a web app, and on the browser, as a browser extension. So these are the 4 things I'm going to talk about. The idea here is not to go deep into any of them, but just to talk about the main aspects of each, so you get an idea. So I'm going to talk about GraphQL, React, Rails, and Relay. So it's not only a Ruby talk, so it's half Ruby and Rails, the other half is JavaScript. I hope you are fine with that. So here is how those things divide. In the highest level, we have GraphQL and Rails on the back end, and we have React and Relay on the front end. So let's start with GraphQL. So GraphQL is a query language that was developed by Facebook. So you can use that to declare how your API works, and you can execute queries to fetch data from your backend by writing those queries. To make it easier to understand, let's first compare with REST, which I think many of you are already used to. So here is a small screen of how our fact-check application looks like. We have, for example, a video of something that happens, and we have many users working over it, trying to determine the truth about it. So here is a very illustrative example of Avengers, and Bruce Banner saying, "Oh, I don't remember anything that happened at the video," because he doesn't remember when he's Hulk. But anyway, so here the small parts of the data model that's being represented here contains a media. This media can contain many tags, and can have many comments by different users. So we have this small portion of the data model with 4 classes. On REST, how would us fulfill this UI? So we could have different API endpoints to fetch all that data that we need. So we would need to make many different API calls in order to fetch all the data we need. Another way to do that would be to have less API endpoints, but that take parameters, so you can tell which fields you want and how many of them. So, and yet another approach is that you keep adding new API endpoints just to do everything that the UI needs. So if you have a team working on the back end and another team working on the front end, and we had that before we migrated to this architecture, the people from the front end team are always asking, hey, now we need an API endpoint to fetch this and that. Now I need an API endpoint to do another thing. And you keep implementing new API endpoints, and then your API becomes a mess. So you have too many requests and too many different API endpoints to do everything you need on your front end. So that's where GraphQL comes. First of all, you have just one endpoint as far as HTTP is concerned, which is a post endpoint to the /GraphQL that works by convention. So you do a single request to this API endpoint passing a query parameter which contains your GraphQL query, which looks like a JSON. It's not exactly a JSON, it's its own syntax, but it's pretty straightforward to understand. So this query says that I'm asking for a media with ID 1 with some fields, and then I want some tags and comments of that media, and then I also specify which fields I want for each of them. And then we can see that there is a visual equivalence between the query that we're sending to the backend and our data model by the way that the fields are nested and such. Makes sense to what we have on our data model, so the code becomes easier to understand. So when I make this query to the backend, what's going to return to me is a proper JSON with the structure very similar to what I asked and just containing the data that I asked for. So we have a single API endpoint, and we have a very high level of flexibility of the different combinations between fields that we can ask. So when it comes to Rails, how does that work? There are two ways to do that. You can create a new application from scratch. At Midan, we implemented a Rails template for that. So we can just do Rails new, clone the code of the template and pass the parameter to it. It's going to generate a new Rails application for you, which doesn't have any view. It's a headless API, which comes with built-in support to GraphQL and also REST as well, and Docker and authentication and all that stuff. Or you can add GraphQL to your existing application, and then there is a Ruby gem for that. Just need to add the gem, implement one controller with its own route, and then add an initializer that's going to load your schema from your local file. And that's it. It's just 3 steps, and you have a Rails application with GraphQL support. When it comes to Rails, how we define each of the GraphQL types to our existing models. So each type by convention is saved in a different file under app.graph_types. And then we use the GraphQL object type define to define each of the types and each of the fields. And by default, you don't need to implement a block for each of the fields. And as we just learned, blocks are evil. So you can just leave it as there, and Rails is going to look for that method defined in your model. So for field title, it's going to look for an attribute or method title for that model. Or you can be brave enough to implement your own block, and for collections, so for things that you expect to return more than one value, implement a connection, which can receive arguments, which are just parameters and such. So everything I talked so far is about how to retrieve data from the backend. How can we make changes to the backend? That's where mutations come into play. So when we talk about the CRUD operations of our application, everything I talked so far about the GraphQL queries are on the read part. Mutations are the parts responsible for creating, updating, and deleting stuff. The way that a mutation looks like, it's very similar to a GraphQL query. So we have a mutation name, and then we define the input parameters to it, so the stuff that we're going to send. A client's mutation ID is always required as well, so it's just to keep in sync between the backend and the front end. And at the last block, you defined what we want the backend to return for you as a result of that mutation. So on this example here, I'm calling a mutation to create a new media based on a URL, and I expect the backend to return to me the ID of that media that was just created on the backend. So when it comes to Rails, how you define that? So the gen also provides for you a way to define mutations and just define two things. Three things. You define the input field, so this is the things that are going to be sent to your mutation. So also based on the previous example, what I send to my mutation is just a URL. That exclamation mark just before the type tells that that is a mandatory parameter. If it's an optional, you just need to put the type without the exclamation mark. And then on the return fields, which fields that the front end can ask for you as a result of that mutation. And then on the resolve block, that's what your mutation actually does. So on my resolve block, I'm just instantiating a new media class, setting the URL to the one that was passed as an input parameter, and then saving it in the database. And that's almost on the highest level as far as the backend is concerned. Now let's go to the front end. So on the front end, we have also an equivalent library, also developed by Facebook, to make this interface with a GraphQL backend much easier. First, talking about React, it's another JavaScript framework as every day. So we are now 0 days without a new JavaScript framework. And that's one of the things that everyone should do in your life. I need to create my own JavaScript framework and plant a tree and write a book and that stuff. So back to our UI, how would we implement a front-end application for this simple interface on a regular MVC JavaScript framework? So we'd have a controller with all the actions that we expect that UI to do. And then we have our view with all the HTML and markup to display that information. And then we have also code for all the interactions and events that are expected to happen on our interface. So we have this separation into concerns. So we have parts of the code responsible for the controller, we have parts of the code responsible for rendering, and we have parts of controller responsible for interaction. When it comes to React, it's a completely different way of thinking. So everything in the interface is called a component, and components are made of other components. So this interface would be a big media component made, for example, for that tag list, we would have a tags component made of other tag components. And then the comments list would be a comments component itself made of other comments components. So that's the way we would implement that. So we can see this difference between concern separation and component separation. So in React, this is the rule number 1. Everything is called a component. And by being a self-contained component, it makes a few things much easier. So they are more easily testable, and to implement unit tests for that component without needing to worry about everything else that is around that makes you focus a lot. And they are composable. You can mix different components to make new ones, and reusable and maintainable because you don't mix much of them. So using a very specific and small example. So we have a tag here on this interface. And the tag just has this border and a name and an X, so you can remove that tag. So how would that look like as a React component? You can implement a new class that extends the default component class that is exposed by the library. And then you implement all the methods related to the behavior of that component. So here I just have a delete method, which is going to trigger a mutation that receives that tag ID and deletes that tag from the backends. I'm going to talk more about mutations soon. And then you have the render method, which is responsible for actually rendering that component. So on the return part of that method, you are supposed to write your HTML, which is not really HTML, that's called JSX, which is a mix of HTML with some with other React components and such. This is going to be run by your preprocessor, and it's going to be converted by plain HTML. So it can look a bit confusing at a first glance that you are mixing markup with logic code in JavaScript, but you get used to it. So another thing that you can notice from here is that we don't have any code to make interactions between our interface. So we have that on-click code that you can see over there that's going to delete the tag when I click on it. And what it's going to do is just to commit that to the backend, and you don't see anything here saying that I'm going to hide or to remove that from the DOM, because React is going to take care of that automatically for you, and that's rule number 2, that is going to rebuild the whole thing on every change you make to the states of the data. So it can sound a bit costly at a first glance that everything is going to be rebuilt, but it's actually not, because it has something called virtual DOM. So it's going to load a structure of your markup in memory, like a tree, and it's going to calculate the difference between the current state and the previous state, and it's going to make actual changes to the DOM only where it's changed. You don't need to worry about that. So it's actually faster than if you had to worry about this thing. So you always write your code expecting how it should look like at different states. And that's where we get into states. So this is how you control the information on your components. There are 2 ways. One way is using the props, which are immutable. So you're not supposed to change that. Props come from the parent components or from the backend. And so what we have on this example as props. So we have the tag ID, for example, it's not supposed to change, right? And we have the tag value, which is not supposed to change either. And then on the states, that is where we control things that are expected to change during the interaction of the user with our interface. So here we have the state saying if the component was deleted or not. And here on the handle deletion methods, I'm changing the state saying that the tag was deleted. And here on my render method is where I say if the tag should be displayed or if I should display something saying that it was just deleted. So we never change the markup directly. We just write our code with the different situations of the different states, and this way we don't need to worry about all those synchronous problems that we can have sometimes. So React is made basically for web, but there is a branch of that for mobile applications, which is called React Native. So it follows the same conventions of React, with states, with props, and all those things, but it's made for mobile. So of course, it doesn't support HTML. So one basic difference between React and React Native is that HTML tags are not supported. Of course, you basically have views and text components, and then you need to do everything based on that. But there is a library called React Native Web, which you can have a single markup code for React Native, and that gets compiled to HTML when it comes to the web. So we can have that very same code here and compile it using React.js as a web application, or compile it using React Native as a mobile application. And this is how we do it on our hybrid applications, for example. So how can we get those data from the back end to fulfill our front end code? This is where Relay comes into play. So it's to make this connection between GraphQL and React. and it's also a library from Facebook. So this is how basically it works. We have the server, which is our Ruby on Rails backend API with GraphQL support, and we have our components on the front-end side. So all those actions that trigger mutations, for example, on that delete tag operation that I just showed, it's going to trigger a request to the backend, which is going to return a GraphQL response to the relay store, which is going to send all the data as props to the components, for example, that tag ID that I just showed before. So relay keeps this local storage of all the data that you request from the backend. This way, it never re-requests data that you already have if it didn't change. So if you are browsing your application and you go back to a page, it's not going to trigger another request to the backend because the data is already there on the relay store. So it makes the performance of your app pretty good. And another thing that it does is even when you run mutations, for example, if when I delete a tag, it's not going to re-query the backend to get the tags list again. For example, I'm just going to tell relay to remove that tag from my local store, and then I have the data in sync between the front end and the back end without needing to request the data from the back end every time. So this is another diagram to show better how this integration works. So we have our GraphQL server and relay in the middle. React's components make GraphQL requests to the backend through relay, and those information are going to return as props to the components, so as immutable data. This is thing how. And again, let's go to mutations, how those operations happen on relay. So let's take as an example now how would we add a new tag using relay. So all those methods names, they are by default from the library. You just needed to implement them. So in order to have a minimum working mutation, you needed to implement at least those 4 methods. The first one is the mutation to be called, is just the name. So here I'm saying that I'm going to call a mutation create tag. And then on the expect return, I'm going to tell which are the fields from the backend that I want as a result of that mutation. So after I call this create tag mutation, I expect the backend to return for me the new tag that was created, and that's called the tag edge. And I'm also calling the updated list of tags under that media, but in that case that wouldn't be necessary. That's just to illustrate how you can ask for more data. And the input parameters that are going to be sent to the backend. In this example here, I'm just passing 2 fields, which is the tag itself, the tag value, the text, and the media ID of the media that I'm tagging. And then as the getConfigs method is one of the most important ones, because it's the one that tells how am I going to update the local store of data that I have on my front end with the information that came as a result of that mutation. So the getConfigs is pretty complicated to understand because the names on the fields are not very straightforward. But let's try to understand a bit here. So the type of the operation that I'm going to run as a result of that mutation here is a range add. This range add says that I'm going to add a new data to my local store. There are others like range delete and node update and fields update. This one says that I'm going to add the new data that was created as a result of that mutation to an existing collection in my local store. So for the range adds, I need to specify a few things. First is the parent name. So here I'm adding this new tag to a media. The parent ID, so I can identify that media in my local store. So I need to pass the media ID. And the connection name is the collection that I'm going to add this new tag, which here is called tags. And the edge name is what was the object that was returned from the backend, and that I'm going to add to the tags collection of this media, and it needs to match one of the fields that you asked on the fetch query as a return of your mutation. And then the range behavior just tells where in the collection I'm going to add this new object to. So here I'm just appending it to the end of the list. So for each of the different type of configs, you have a different set of fields that you need to specify. And that's everything in the documentation. Not exactly clear, but it's there. So back to the same example I had before. How do you call a mutation? So you call the relay store commit update, instantiating a new mutation and passing all the input information you need. For a delete tag mutation, everything I need to specify is the ID of the tag that I'm deleting. So that's pretty easy. So using this whole stack of GraphQL, React Relay, React Native, we are able to implement this architecture that I was talking about in the beginning. This way, we can have one code only on the front end that runs in different platforms. We have a generator for nodes that creates a very basic front-end application that is meant to be run in different platforms, and that comes with GraphQL and relay support. So we use that on our applications, and the repo is here. So after you create an application with that, you can have, this is what you are going to get. So if you compile the application for the web platform, you can run it as a web application, and you can pass URLs as parameters on and it's going to load for you. Because it needs to come with an example of how to receive input parameters, right? Because if you have a web application, it's different from the way that you receive input data from a browser extension or from a mobile app. So the way we do that is by receiving URLs. For a browser extension, just pass another platform, and the extension is able to read the URL from the current tab, or if you right-click a link, it's able to read the destination of that link. And for the Android application, you are able to invoke your app from the share menu and get whatever was shared into your app. This is our real-world example. The repo is here. It's called the checkmark. It's our application to send media to be verified. And we have this mobile application and this browser extension. For example, you can see that they look exactly the same, and they are the same code base. They have different ways to receive the input data. But you can see that localization works for both. That's why it's in Portuguese. And it runs as a native application with a very good performance. And here it runs as a browser extension for Chrome and Firefox with good performance as well. And for us, it's much easier to maintain a single code base and having a good performance on different platforms. So this is basically everything I tried to cover. I know it was too much, so thank you for listening. The slides are here, and that's my handle, that's my website. Thank you.